Hello, 704, 705, 706. Dr. K here. Happy Friday. I am not here with you in person. I'm here virtually with you. I want to make sure that I recorded a lesson for you, and it's very important that the teacher you are with right now, substituting for me, make sure you show them the utmost respect. Give them a math genius, honorable welcome. Listen to everything they do, everything they say, do everything exactly as they tell you. I want to hear back that you did really well, that you showed them great respect, you followed their instructions, and you did the lesson that I'm about to teach you right now. So it's very, very important. I will be checking on you. So the lesson, we're going to use the big book, right? The big book, 2B. I want to make sure I see it in the frame, right? The big book, 2B. And we're going to go to page 212, 212. I have it right here on the big screen. And the lesson, we're going to learn about what is a histogram. What is a histogram? So I'm going to pause right now, or maybe the teacher can pause me right now. Just make sure everybody's got their big book. Everybody has their big book already. It's under your chair. Take out the big book. Remember 2B, and it's page 212, 212. It looks just like that. So, very important. What is a histogram? First of all, let's just take a break. Here's an example. Information. Solving a histogram problem. Here's a problem. Here's some information. The table shows the heights of 78 trees in a park. And the heights of those trees are rounded to the nearest foot. So this data set is about trees. Trees in a park. How high, how tall these trees are. I love trees, so this is very important. I love things like this. So we took the information. If we had to list the data set, if we had to list out the data set, how many numbers would it be? Take a few seconds and discuss. You could even pause this video. Remember, data set, 78 trees. If I had to list out the numbers, how many numbers would it be in that data set? Okay, we're back. What do you think? Did you get 78? That is correct. 78. So this data set is really a list of 78 numbers representing 78 trees. And of course, these trees are not all carbon copy the same size. Some are short, some are tall. So the trees are different sizes. And it's all about looking at the information and summarizing the information. And we want to use statistics to summarize this information. So here's what I did, because we are math geniuses. Rather than just give you 78 numbers representing the height of each one of those 78 trees, we organized the data a little bit. Let's look at the table. So, trees that are between 60 to 69 inches, trees that are between 60 and 69 feet, we counted how many there are. Trees that are between 70 to 79, we counted how many there are, and so on. So where do you see 78 here? That's a question. This is a good time to pause. Where do you see 78? What happens if how can I get 78 out of these numbers? Let's pause. Okay, we are back. I was claiming this is the data of 78 trees, telling you how high the trees are. We don't have exact information of every tree, how tall it was, but we know that there are 11 trees between 60 to 69. And my question was, well, where do you see 78? The answer is, and I know some of you got it, if you add them all up, If you add all these numbers up, you get 78. And do it by hand or do it with a calculator. You can do this. Add all these numbers, you will get 78. So that's amazing. So let me ask you this. Do you have, what is the height that you see more frequent, more often than any other height? Is it trees that are in the 60s, in the 70s feet, in the 80s, in the 90s, and the hundreds, and the hundred and teens, 110s? What do you think? That's another question. Discuss with your classmates. What do you think? What is the most frequent height for these trees? Let's see. Another good time to pause, discuss, explain to each other, don't leave anyone behind. Pausing, pausing, pausing. I could solve a Rubik's Cube meanwhile. No, just kidding, just kidding. Okay, and we are back. So we see how there are 80. If you said 80 to 89, 22, that tells you that there are 22 trees that are how tall between 80 to 89. So we don't know exactly how tall these trees are. We don't know if they are, for example, 80, 81, or 82. We don't know if they're all 84. We just know that there are 22 trees in that park that are between 80 to 89. Does that make sense? I want to make sure, math geniuses, I want to make sure we got this. 704, 705, 706. Does that make sense? So now, I can ask you a million questions about this data set. I can ask you a million, that's not even enough. A bazillion questions, that's not even a real number. A quadrillion, I don't know. I can ask you infinite questions about this data set. For example, how many trees are between 70 to 79? And you can say, Dr. K, that's easy. What did you say, Dr. K? How many trees are between 70 to 79 feet? Meaning they could be 70, 71, 72, 73, 74, 75, 76, 77, 78, 79. How many trees in that park, out of the 78 trees, are in the 70s? And you would answer, oh, that's easy, Dr. K. There are 20 trees. If I asked you, oh, well, what percentage of the trees are in the 70s, from 70 to 79, you could say, oh, Dr. K, percent of trees between 70 to 79, that's equal to 20 out of 78, right? Multiplied by 100. And you could tell me what percentage that is. And of course, you could do it with a calculator. Let's see. 20, you probably beat me to it. You probably do it in your head because you're math geniuses. I don't want you really to do it in your head. You can use a calculator and multiply by 100. And this is what? 25.6 rounding percent, rounding to the 10th of a percent. So I can say, oh, about a quarter of the trees are in the 70s, from 70 to 79, the height of them. So remember, we are on page 212. We are in the big book, right? Which is the 2B book. And we are on page 212. And I expect this to be all noted. I expect when I come in on Monday and I see it, I expect all your pages to be sorted out, solved, explained. You don't have to copy everything word for word. I just expect that you understand it. I expect that you pretty much know how to answer questions if I had to ask about that. Does that make sense so far? So really, it's a data set. Let's review one more time. It's a data set of 78 trees. And all we know about the trees is how high they are, how tall they are. They're all measured in feet. We are consistent. The shortest tree, we don't know for sure, but it's in the 60s, from 60 to 69. So it could be 60, it could be 69, really. We don't know what the minimum is. We know that it's in the 60s, from 60 to 69. And we don't know what the maximum is. We just know that there are 4 trees from 110 to 119. Very, very important that you understand what this table tells you. That is a table, a frequency table. And from there, somebody might come to you and say, hey, Dr. K, you know what? Table is beautiful. That frequency table is beautiful, but my brain works better with a graph. And I can say, oh, that's easy. We are math geniuses. We could do anything. Instead of giving you this information in a table, I can give you that same information, or you can, or we can give you the same information in a graph. And that graph is going to be called a histogram. A histogram. And here it is. And my argument, I argue that the same information in this table also exists in this histogram. The same information. In fact, I can pinpoint to it, and we'll go over it again all of next week. Look at that. Do you see? 60 to 69, for example, or let's go with a different number. Let's go 100 to 109. 100 to 109, right here. 100 to 109. There are 6 trees that are 100 to 109. And that information is also in the graph. Where is the band that's 100 to 109? Right here. And guess how tall is the bar right there? 6. Do you see that 6? That's the same as here. And do you see that band? 100 to 109? That's the same as over here. So it's the same information. Now, this is a good point to discuss. Who here likes the table better? Who here likes the histogram better? So right here on your notes, I want you to write which one you like better. Maybe put a little star on where you like better. So on Monday, when I come back and I see your books, I expect either that you have a star here saying, oh, I really like the table better, or I expect you to have a star here and I say, oh, I like the histogram better. So it's all about, I don't want to do too much work for you, but I really wanted you to have a good Friday. I want to recall prior knowledge of histograms and frequency tables. I'm not here, but I wanted to make sure that you have that information recalled and that you read it and that you make sense and you really pay attention and you are really respectful and you're having fun and it's a good Friday. I expect you to really go over this and truly understand it. And try to even make up your own questions. Make up your own questions. And you could even say, you know, how many trees are, for example, here's a question, a combined question, like an interesting question. How many trees are 100, or how many trees are 100 feet or taller? How many trees, let me write this down. How many trees in the park out of the 78 are 100 feet or taller? How many trees are 100 feet or taller? So take a few seconds, discuss with each other. And I hope that you got this right. I know you got it right. I just hope that everybody understands it and sees it. Right? How many trees are 100 feet or taller? Well, okay, maybe a good time to pause. Let the students discuss for 3-4 minutes. And I'll come back. Let me go. Pausing. Let me come back. Okay, so let's see now. It's not those 11. Those are less than 100. They're in the 60s. It's not those 20. They're 70, 79. They're too short. It's not those 22. It's not those 15. How many trees are 100 feet or more? Well, they could be 100 to 109, or they could be 110 to 119. There are, did you get 10? If you got 10, then that is the correct answer. There are 10 trees that are 100 feet or more. You have to be a math genius, and part of being a math genius is understanding what a frequency table looks like, and how to interpret a frequency table, and even how to create a frequency table if I had given you the raw data of each of the 78 heights of the tree. And then also try to understand that the histogram is telling you the same information as the frequency table. Now, how can I get that 10 number out of the histogram? How many trees are 100 feet or higher? Well, here is the height. 100 is right here. The cutoff is right here. So all these trees are too short. All these trees on this side are too short. And the trees that are 100 feet or taller, 100 feet or higher, are these trees. And how many are there? 6 and 4, also 10. Does that make sense? 704, 705, 706. Again, I want to make sure that you understand this. I want to make sure that you can understand this and explain this forward, backward. And I want to make sure that you go from test takers to test makers. That I can even give you a homework where you are making a test. And I think that was a great idea. So think of all the questions that you could come up with based on this. That's all I have for you. I want to make sure that you discuss this over and have a great lesson. Again, on your best behavior, I got to make sure that when I asked for feedback, I got to make sure that everyone told me, oh my goodness, Dr. K, 704, 705, 706, amazing kids, math geniuses, very respectful, very good kids. I want to make sure I hear that. And have a great weekend. I love you. My job is to make you a math genius. Bye.